Hello everybody, welcome to the logical domain of DJ, where you can learn mathematics more easily, more logically and more technically. So let's begin with the session. Today's session is transformation of sums and product of trigonometric functions. That is, here we transfer the sum of sine and cosine formula into product, and also the reverse, that is product of sine and cos functions into their sums. So start with starting the formula, basic formula. What was sine A plus B and sine A minus B. Everybody we know these two fundamental formula. What are they? This one sine A cos B and cos A sine B. What is sine A minus B? Sine A cos B minus cos A sin B. These are very common formula to everybody. This one 1 and this one is your 2. If you add them, that is 1 plus 2, then what you will get? I first add the right hand side. If you add them, these terms will be vanished. They will be 2 into sine A cos B, and the right side will be sine A plus B plus sine A minus B. See the structure of this formula. The left hand side is written in product form, product of sine and cos, and the right side is written sum of two sine functions, that is sine A plus B and sine A minus B. So that's why this chapter is named as transformation of sums and product. In this formula, we transform the product into sum. Similarly, if we subtract them 1 minus 2, then what you will get? If you subtract, these terms will be vanished. You will get 2 cos A sin B equal to sin A plus B minus sin A minus B. So we get our two required result. 2 sin A cos B equal to sin A plus B plus sin A minus B, and 2 cos A sin B equal to sin A plus B minus sin A minus B. I also write another two structure which will come from the formula of cos, that is cos A plus B and cos A minus B. What is cos A plus B? Cos A plus B equal to cos A cos B minus sin A sin B. And what is cos A minus B? Cos A cos B plus sin A sin B. If this one 3 and this one as 4. If you add this one 3 plus 4, what you will get? This term will be vanished. So 2 cos A cos B equal to cos A plus B plus cos A minus B. And if you subtract them, now I subtract 4 minus 3. 4 minus 3. Why? Then this sign will be positive. Then this will become 2 sin A sin B equal to cos A minus B minus cos A plus B. There are another two formula where we have transferred sums of sine and cos into their sums, sorry, product of sine and cos into their sums. So this four formula here, product are transferred into sums. Now how can we remember them? We already know how they come from the fundamental formula of sin A plus B and cos A plus B, and this is this just by adding and subtracting the formulas. Now we have to memorize this. How can we remember them? See, when we transfer the product into sum, that 2 is mandatory. See, all the formula have 2 in the product form. So this is our first observation. That is, when we transfer the product into sum, there must be a 2. Now see what is the combination of the product. For the sine structure, the combination is sine with cos or cos with sine. But for cos structure, the combination is cos with cos or sine with sine. That's also related to our fundamental formula, sine A plus B or sine A minus B are combined with the sine and cos, and cos A plus B and cos A minus B formula are combined with cos A cos B, sine A sine B. That's why this formula also are in the same structure. So sine structures are in the combination of sine cos. If their sine is the first term, then sine A plus B plus sine A minus B. But if cos is the first term, then sine A plus B minus sine A minus B. Now here is a confusion. Sir, as that is a product form, so I can easily write cos here, sine in the right side. Whatever you write here also, if you take the sine first, then this sine will be plus. If you take the cos first, the sine will be minus. The formula will be combined as they are given a sine. Whatever you take, which one is first, sine or cos, it's not any problem, but it will not create any problem in the formula. I will do a little problem, then your concept will be clear. But our thinking is that if their sine is first, this sine will be plus, and if their cos is first, this sine will be minus. Now for the cos structure, if the product are in forms of cos, there is no confusion. If they are cos, this sign will be plus. If they are sine, their sign will be minus, but they are also an exception. Here A minus B structure is before A plus B. This one is exceptional among these four. All these four structures, A plus B angle is the first term, but in the last formula, A minus B structure is the first term. So in this way, you will remember these four formula where we transfer the product into sums. That is 2 sin A cos B equal to sin A plus B plus sin A minus B. 2 cos A sin B equal to sin A plus B minus sin A minus B. 2 cos A cos B equal to cos A plus B plus cos A minus B. 2 sin A sin B equal to cos A minus B minus cos A plus B. So clear to everyone? This is our first four formula where we transfer the product into sums. Now here we also prove another four formula where we convert the sums into product. These are also coming from this formula actually. If we replace A plus B equal to C and A minus B equal to D, then what is A? A equal to C plus D by 2 and B equal to C minus D by 2. That is when we remember the formula from right side to left side. We will not remember in this form. We will think this is a single angle and this is a single angle. That's why we write A plus B as a single angle C and A minus B as a single angle as D. Then what it will become? Suppose if we write this formula, this will become sin C plus sin D, this one equal to 2 sin A means C plus D by 2, C plus D by 2 and cos C minus D by 2. That is our first formula when we transfer the sum into product. We remember the formula in this form, CD, sin C plus sin D equal to 2 sin C plus D by 2 into cos C minus D by 2. If we replace this value in the second formula, what we will get? Sin C minus sin D equal to 2 cos C plus D by 2 into sin C minus D by 2. That is our second formula. And for the third formula, it will become cos C plus cos D. Cos C plus cos D equal to 2 cos C plus D by 2 into cos C minus D by 2. Up to this, it is very conventional, just coming from this structure. Now for the last one. Last one is, you see, this one is our D, cos D minus cos C. This one will be 2 sin C plus D by 2 sin C minus D by 2. So this structure is little different from the above three structures. So we convert the structure in the same structure, in the same form, that is, we convert it into cos C minus cos D. That is, we take one minus sign from the left side and we replace this minus sign to this sign. Then this will become 2 sin C plus D by 2 and sin D minus C by 2. You know, sine of minus theta equal to minus sin theta. That is, we take one minus sign from this angle. Then here also one minus sign will arise. Here also one minus sign will arise. This 2 minus will vanish. So we take this structure for the last one. This one not. We will take this one, cos C minus cos D equal to 2 sin C plus D by 2. Here is the exception, sin D minus C by 2. In every case, C minus D, C minus D, C minus D. But for the last case, D minus C by 2. So for the first 4 formula, the last formula was there is an exception, and here also 4th formula, in the last formula there is an exception. So we have to remember them. That is, sin C plus sin D equal to 2 sin C plus D by 2 cos C minus D by 2 sin C minus sin D, 2 cos C plus D by 2 sin C minus D by 2 cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2, and cos C minus cos D equal to 2 sin C plus D by 2 sin D minus C by 2. So here also you can remember, when we transfer or convert the sums into product, 2 is compulsory, and when we take the sums of sine, there will be combination of sine and cos. When there is plus, sine is first, sin C plus D by 2 cos C minus D by 2. When there is minus, cos is first, C plus D by 2 sin C minus D by 2. And when they are the combination of cos C plus cos D or cos C minus cos D, when they are the plus, 2 cos C plus D by 2 cos C minus D by 2. That is, both the terms are in cos. And when there is a minus, both the terms are in sine. So in this way, you can remember the formula. Also, when you do the sum, this formula will be memorized easily to everyone. So these are our 8 formula. Actually 4 formula. We just remember the product form in their structure and the sum form in this structure. So I think it is clear to everyone. Now I just give one simple example, just how we apply this formula to the problem. Suppose here is a problem, sin 75 degree plus sin 15 degree by sin 75 degree sin 15 degree. So how can we apply the formula in this problem? You can think this one as sin C plus sin D. Here 75 is the C, 15 is the D. So what is our formula? We will transfer the sums into product. So 2 is compulsory, as this one is plus. So sin first, C plus D by 2 C minus D by 2. Now for the denominator, sin C minus sin D, we will transfer the sum into product. So 2 is compulsory, as this one is minus, so cos first, cos C plus D by 2 sin C minus D by 2. So what you will get, 2 to cancelled, this one is sin 75 plus 15 means 90 by 2 means 45 degree. Cos 75 minus 15 means 60 by 2 means 30 degree. Cos 45 degree, sin 30 degree. So you know sin 45 and cos 45 are same value, so you can cancel them. Cos by sin, that is cot 30 degree, cot 30 means 1 by root 3. Sorry, cot 30 means root 3. Silly mistake. Cot 30 means root 3, not 1 by root 3. So in this way, we can calculate the problem. The converse problem in this way, if we transfer the product into sum, suppose cos 40 degree, cos 80 degree, how can we transfer the product into sum? So how can we approach? First of all, we see there is no 2. Whenever we apply the product into sum, 2 must be arise here. So first of all, we apply it 2, and for better calculation, we take the larger angle first, that is we write cos 80 first and cos 40 later. That is our first technique to avoid miscalculation. We take the larger angle first term and smaller angle second term. It will not problem because this one A dot B, we can easily transfer them. So what is 2 cos A cos B? This one is cos A plus B plus cos A minus B. So this one is cos 120 degree plus cos 40 degree. You can calculate this value, but this will remain same. What you can write, cos 120 means 180 minus 60 plus cos 40. So 180 minus 60 means this switch in second quadrant, and in second quadrant cos is negative. This one is even power of even multiple of 90. So cos will remain cos 60 plus cos 40, and this one becomes half of cos 60 means half cos 40. So that's our calculation. In this way, we can apply the formula into our calculation. So clear to everyone? So I think all the formula deductions is now clear to everyone. I think you get more confidence about the formula, and obviously in the next video we will do some important and technical math on this chapter. So if you think this video is helpful to you, don't forget to like, share and subscribe the channel, and also press the bell icon to get the video notification on your mobile. So that's all today. Till then, keep your math practice always, keep practicing, keep growing, and keep learning every day, so that math becomes very interesting and very joyful to everyone. Thank you. See you in the next video with another powerful mathematical session. Thank you.